Well, good afternoon and welcome to this video. And so we're going to be solving some more exponential equations. And in the last video, if you'll remember, one of the last ones, worksheets that we did, we took things that had bases in which we could write them the same. So in this case, I could actually write 125 as 5 cubed, and then I could actually calculate out what x was. On the video that we're going to be doing today, we cannot write them into the same base. In other words, I cannot take a 6 and write it with a base of 18, or I can't write 18 with a base of 6. And so what we must do then is use what we've learned on the last video of how to take an exponential and change it to a logarithmic equation. So I'll run through some examples here for you. So, and on this is cut off, this again is to the thousandths, and that's the typically where we will always round, is to the thousandths. So that is just always, no matter what, even if I don't write that on a quiz, test, whatever, it's always the thousandths. So we're going to write this as log base 16 of 18 equals x. And again, using that B, A kind of backwards, if you would. So base, answer, exponent. Okay? Now, since I have it this way, I can do our change of base property and just run that in my calculator. And so again, if you get your calculator out, let me get mine out here real quick. We'll do that. So we have log of 18 divided by log of 6. And again, we're going to round it, so x equals 1.613. And again, when you are doing these problems, I do expect to see, one, this step, okay, this step, and your answer. Now, others are going to require more work, but definitely I need to see each of them. So what I'm showing you here is the expectation that you will do on your worksheet or test. So now in this case, I'm solving for this. That is my exponential. So I'm just going to need to move that 3.3 over to the other side. So I get 7 to the n equals, what is that, 2.7. Make sure I got that right. Trying to do things in my head. Yep. And so now then I am going to do my change of base. Might change it to an exponential. So log base 7 of 2.7 equals n. So log of 2.7 divided by log of 7 equals n. And then I'm just going to run that in my calculator again. So log of 2.7 divided by log of 7, and round it. So it is 0.510. So that's number 3. Okay? Now those are kind of scrunched together, so I'm just going to come over here to the side and do number 5. Now, just like any equation that we do, we are solving for the function piece of it. That is the function right there, 3 to the n. And so when we go to solve this, I am going to need to get rid of the 1. Whoops, forgot to change. So plus 1 to both sides. That would be a negative 61. I'm going to divide by the negative 5. Okay, so do not ever try to write this in logarithmic form until you just have the base and the exponent. So what I mean is this is now base exponent. And then I'm going to put that in my calculator, 61 divided by 5, and that is 12.2. Now, if in case that 12.2 did not come out even, then I would need to round to the thousandths. Now I am going to rewrite it as log base 3 of 12.2 equals n, which is log of 12.2 over log of 3 is n, and I'm going to run that in my calculator. So log of 12.2 divided by log of 3, and my final answer here would be 2.277. Okay, final answer. Okay. Number 7. I'm probably not going to have room for all this, but we'll try to fit it in. It's possible you might want to put some of these on your own paper instead of on the worksheet, because I did kind of make this with not much space. Okay, so again, this is my exponential right there. Even though there is a number in the exponent, that's fine. So I'm going to write it log base 11 of 83 equals 8.1x. So what I would do in this case, you can do it one of two ways. I would probably go ahead and put this in my calculator and simplify it. Okay, and then I'm going to divide off the 81. Okay, now you could write it all as one step, but as far as putting in your calculator, it's going to definitely be easier. So log of 83 divided by log of 11. Always check my numbers because I'm horrible with sometimes typing in the calculator. 1.843. Now I'm going to divide off that 8.1. So one of the things about these type of equations versus the equations we've had in the past is that a lot of them are not exact on there. So I get a final answer of 2.27. Now, I'm really bad about also, so sometimes my answers don't match up, is leaving this number unrounded in my calculator and then just dividing off the 8.1 and rounding my final answer versus rounding at that point. And you're welcome to do that also, if you understand what I'm talking about, but I would definitely in this position put it as a rounded number. Yeah, I hope that makes sense. So if sometimes my last value is, let's say 2.226 versus 2.227 or 2.228, and you're like, well, I didn't get the same last number, it's because I'm lazy and I don't take out that exact value and put in the rounded value. I just go ahead and divide off the 8.1. And again, if you do the same thing on a test, quiz, whatever, I'm going to know that that's what you did. If what I just said doesn't make any sense, you can ask me what I meant by that. Okay, let's go ahead and do number 9. And negative 2 times 4 to the n minus 1 equals a negative 32. Again, this is my function. I like to highlight that so that I know which piece that I'm solving for. So in this case, I am just going to divide off, get my exponential. Now I'm going to go to log form. Okay, and again, I'm going to run that number in my calculator. Do be sure it is always the log of your large number over the base. Okay, and then again, I'm going to run that in my calculator. So the log of 16 divided by the log of 4. That is 2. Probably could have done that in my head. And then move your 1 over. So in this case, n is 3. Now, one thing I didn't mention, because you can definitely always go back in and check that value. You can just run in your calculator negative 2 times 4 to the 3 minus 1 and see if you get a negative 32. So these can be checked. It's not a bad thing to go back in and do. Okay, I don't have a timer on, so I don't know where I'm at on, but I'm guessing this video is going a little long, so I'm going to stop now and do the rest of the problems in the next video. If you don't have any questions about this, especially those of you in honors, then you can possibly skip the next video.